Hi everybody, welcome to another video in statistics. Section 2.2, organizing the quantitative data. So in this section we focus on quantitative data, the data that deal with number. Right, organizing discrete data in a table. Right, and discrete is the type that with the countable or finite amount. So here's the first example. The first step is summarizing determine the data discrete continuous. So if it is discrete, we can put them in categories. If they're small enough, that will be put them in classes. If the few values, we can will be the observation for each class. If the data is discrete but there are too many values, then we might, or if the data are continuous, we will consider the classes by the interval of numbers. So there are two scenarios here. One scenario is where we have very few data, or for example later we have also more data like continuous, or there will be too many of them. We cannot just give one column for 25, one for 26 degree age years old, and 27. That there were too many columns. So we try to group them together so we have less columns, if you will. Right. So here is for the discrete data. First, this is represent the data. The data represent the number of available cars in a household based on 50 households. Here is what we have on table. Right. So number of cars look like go from only from 0 to 5. Right. Now just count. How many zeros do we have? 1, 2, 3, and 4. Next, how many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It will be 22. Right, how many 3? 1, 2, 3, 4, 5, 6, 7. And then 4 and 5. 4, 1, 2, 3. Yeah. And then the only thing left is that. There's only one of them. Alright. Relative frequency, so we're going to add all of this up, get the total number. Oh, by the way, we don't have to add them up. They're 50. By the way, we still need to add them up and make sure it exactly there are 50 of them, right? $50. Right, now convert to percentage. That should be easy because we divide by 50. 4 over 50 divided by 50 is like multiply by 0.5. I mean 0.2. 0.02 to be exact. So 0.08, which is 8%. 13 over 50. If we do that, we have 0.26, 26%. And then 22 over 50, 0.44. Right. If you wonder why we can get that number, divide by 50 is like multiply by 100, and multiply by 2 and divide by 100. So I just multiply this by 2 and then divide by 100, move the decimal 2 places to the left, right? So multiply by 2 and then move the decimal places. So that's 44%. 7 over 50. 7 times 2 is 14. Move the decimal place. Move the decimal 2 places to the left. 3 over 50. So 3 times 2, 6. Then 1 over 50 is 0.02. Just multiply that by 2, divide by 100, or 2%. Right, so that's nothing different than what we have earlier. The difference here is the type of the data is not as the color of M&M that we have earlier. If it's the color of M&M, we can scramble the order. It doesn't really matter. On the graph, we can just scramble it. It doesn't really matter, right? Right, if you change the color, it doesn't matter. But on here, these numbers have the order, so we cannot change them. Right, so the graph that will be differently defined. So it is called a histogram. A histogram is constructed by drawing rectangles. For each class of data, the height of each rectangle is the frequency or the relative frequency, so either those two, and the width of each rectangle will be the same, and the rectangles touch each other, so there will be no spaces between the bars. There will be the bars, but consecutively. So if we put that together, this is the graph for that example. Right, so we have the column of the bar rectangles, and there's no space between them. Now, so this is for the type of the discrete data or very few categories. Like I said, if there are too many categories, we cannot just draw like 20 bars like this, and that will defeat the purpose of graphing. That will be more complicated. So if there are too many data, or if the data is continuous, we still do the histogram, but a little bit differently. So here's an example of what we're talking about. Classes are categories into which the data are grouped. So, like I said, if there are too many categories, we might want to combine a few categories together. Or if the data is continuous, we kind of put that into range. For example, if we ask anybody from 25 to 64, we're just going to write in the range like this. because we don't want to make one column for 25, one for 26, one 27. In that case, there are too many columns. It will not look very nice. So in that case, we divide that what we call into classes, and so we have for each class, there is the lower class limit and upper class limit. Self-explanatory. And the class width is the difference between consecutive lower class limit. So these are the lower class limit, upper class limit. And if we take the difference of consecutive lower class limit, that is called the class width. So when we draw the graph, we have 25, 35, 45, and 55, of course 65. So the column will go like this. There will be no space in between. Right. Now, the guidelines, the choice of the lower class limit and the first class and the class width are rather arbitrary. Of course, if you want to, let's say between 25 and 64, let's say you can choose like 25 to 30, 30 to, of course we cannot say that, 25 to 30, and then 30 to 35, and so on. By the way, when we put in this into classes, we don't say 25 to 34.9999, but we actually mean 39.4.9999. And then 35 is exactly 35.00001, and then go on, right? So, but in the class, we just put 25 up to 34, even though we know somebody because more than 34 years old, maybe 34 and a half or something like that, we still consider to be from 35 to 34. So that's why that will be the a bar from 25 to 35. There's no spaces between the bars. Right. So only the class limit, low class limit, all those are fixed number. The other one will supposed to be 0.999999, very close to the next class limit. Right. So here more. We choose the smallest observation in the data set, or convenient, slightly lower than that. So if it is lower 25, that would be nice. If we don't want to, round that down a little bit. So it should be lower than the lower and higher than the higher. And generally we should choose so that we have about 5 or 20 classes. And the smaller data set, the fewer classes we will have. And the class width is the largest minus the smallest divided by the number of classes, and round that to a convenient numbers. Right. So next we have here an example. When we look at data set, there's the data, there's a lot of data, and there's also a lot of different categories. So we cannot just put them one column for each time. Right. So the phone data represent the time between eruption for random of 45 eruptions. So there's 45 numbers at Old Faithful Geyser in Wyoming, right? So now those are the data. Like I said, there are too many categories. We have to put them in classes, right? So how do we choose that? So we look at this. We choose the smallest one and the highest one. I label them the smallest one and the highest one. So we list the smallest is 672, and the highest, or just say the largest, is 738. Of course, we can use this number, but conveniently we can round that so that this is a nice number. It's always lower than the lowest, so I go that to 670, and then 738 we can round to 740. Right, we have to choose something bigger so that cover everything. Right, so we have that the fact. Now how many classes do we want? Ideally between 5 and 20. Right, so if there are 5 classes, so we just do this. So for class width, let's say if there are for 5 classes, we take the highest minus the smallest divided by the number of classes. So that gives us the class width. 740 minus 670. If you hit divide by 5, that would be wrong. So ideally, we just want to say 740 minus 670 in the parentheses divide by 5. So the class width is 14. So if we start from 670, so we plus 14 8 times to get the lower limit. Right. Now let's say if we have 10 classes. Same thing. Largest minus the smallest divided by the number of classes. So that is 7. Just do that, but divide by 10. We should have 7. Right. And of course the class width, if we choose something convenient, that will be better. So 14 and 7. If we just round that to 10, that will be the most convenient. So we choose the class width to be 10. Again, something convenient. Right, so keep in mind that will be 10. Right. And if there are 10, how many classes we have? Right, that we determine later. Right, next. So we choose the classes, and then we choose the class. We have 10, that 10 each. The smallest is 670, the largest is 740. Right, next we construct the frequency and the frequency relative frequency distribution. Right, so by the way, let's draw a bunch of rows. Right, so the first one we have from 670 on, and the next one, the class width is 10, so that 680, $690. Like I said, the class width is 10, so the consecutive lower class limit increased by 10. $700 and up. $710 up to, we determine the upper class limit later, and then 20 and 30. Right. So this column is from time, and then first will be frequency, and then the next one is relative frequency. Right. Now, so those are the lower class limit. We start with the smallest number, convenient number, and then the class width is 10, so we add 10 every time. And then the number will be, we know it is going to be less than 680, so it will be 679.99999. Just say 679, 689, 699, 7 and 9, 7 and 19, 7 and 29, 7 and 39. It's not exactly 739, it could be 739.99999. The next one will be 740. By the way, the highest up to 738, so that will be enough. Up to 739 will be enough. Right. The next step is just count how many we have here, and then we just put in the table. Just counting. Right. 670s. How many we have? 670s. 1, and then 2. Right. You can pause the video here. I'm going to pause the video and then count, so we don't have to spend too much time on the video counting. Right. Now if we count, that's what we have. And this said 45 data points, so the total of this will be 45. And then we just divide all of that by 45. Of course, 0 divided by anything is 0. 7 divided by 45. 15.6 degree, 9.45, well that easy, 20%. $11. So 24.4%, and then 7. Oh, we already have that. Right, and then we just construct the histogram. So the difference between the histogram and the bar graph is that the histogram is for quantitative data, so the data have increasing order, and then there's no space in between. Right, so let's draw a graph here. Right, so we have from 670 to 740. If we want to start from 0, just kind of make a wiggly line like this, and we will start from 670 is here. Right, so 1, 2, 3, 4, 5, 6, and 7. Look like there will be 7 columns. So let's see, 3 each. So 7. So we only write the lower class limit. and then the column. I will just use the frequency here. It's to go up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that's perfect. Right. 2, 4, 6, 8, 10, and 12. So here frequency, and here's the time in second. Yeah. So that is the time between eruption in second. So say time between eruption. In second. Right. I'll just base on the table and then put so 670s, there are 2 of them. Again, there will be no spaces. There's no space between the column. Next 0, so there's none. Next 7. And then next there will be 9 for 700. And then there's 9, 11, and then 7. Right. Like I said, there will be no space in between, and only write the lower class limit on this. Of course, we assume that it will go up to almost 680, so 679.99. We'll only talk about that. Right, so that is the histogram using the glass. Right. Next, we use the stem and leaf plots. So stem and leaf plot use digit to the left of the rightmost digit to form the stem, and its rightmost digit form a leaf. And these are the steps to do it. So the stem of data values will consist of the digit on the left of the rightmost digit. The leaf will be the rightmost digit. So we just cut the number. The last digit on the right will be the leaf. Everything on the left will be a stem. Write each leaf corresponding to the stem on the right of the vertical bar. And the last thing is that this have to be in ascending order. Right. Let's see how it works. So it's no secret that gas price fluctuated wildly in the last few years from 1980 to 1999. So according to the energy information, the data below represent the average price in cents per gallon of regular unleaded gas for those years, and then draw a stem and leaf plot for the data. Right, so that's okay. Once again, we separate the rightmost to be the leaf. Everything on the left of that is the stem. So first we're going to draw a vertical bar. Right, the stem and the leaf. The lowest one is the 86, and the highest one is the 131. Alright, so again, the smallest one, the right digit, the rightmost digit is the leaf. Everything on the left of that is the stem. So we have like 86. So if it is 86, the 6 is the leaf, the 8 is the stem, right? So you have the 80s, the 90s, the 100s, 110, 120, and 130. So those are the stems. Now the leaf. 86. We're going to write one number 6 like this. And is there any 80s? There will be no. Well, 80 cents per gallon. Well, those are the time. Right, next 90. 90 and 90. So 90 and 90. Just give some space between the numbers. Right, that's all. Now the 100s. 100. So 10 is the leaf and then 0. So that's 100. 100. And is there anything else? Right, 106. That's it. Now the 110s. 119. 113. 112. 115. 114. 113. 111. 111. 115. And 117. Now the 20s. 122. And then 123. And then the 30s, 130s, there's only one of them. Right. So those are the stems. These are the leaf, stem and leaf. The only thing that I asked you to underline from the previous section, previous page, is that these have to be in ascending order. So I have to put them in increasing order. So one more time. This is just a scratch work. $86, 90, 106, and then 11. Right. This we have to put in increasing order. 1, 1, 2, 3, 4, 5, 7, and 9. And then 12. Right, this is already in increasing order. And then 131. Right, so this is the answer. Right. If we want the legends, we can say by 86, we mean 86. Right, so stem and leaf, very easy. Right, the thing about this is, when we look at this, we know the distribution, so we can say most of them are 110, but we do not know when corresponding to those. Right, next, just like what we have here, if the stem there a stem that have too many leaves, we just chop that into two different stems. Like in this case, like the 3, if there are too many numbers, we have to split it up in 2. Right, so again, the stems and then the leaves. The leaves must be in increasing order. Right. Once a frequency distribution on a histogram of continuous data is created, the raw data is lost. However, the raw data can be retrieved from the histogram or from the standard leaf. For example, if we say between 670 and 679, there are two of them, we will not know how exactly it is. If we just look at this, we say, is that the 271 or 671 or 678, or who knows? But we know that there are two of them between this. We don't know the exact values. So the histogram will not tell us the raw data, the exact data, the stem and leaf. However, will tell exactly how many we have for each data. Right, next, the dot plot. Right, the dot plot is just by the name of it. Like if we have this earlier, and then we just put a dot for each one. So instead of draw a bar, we use a dot. So that also works. Next, the shape of the distribution. Right. So those are the different form of distribution. So uniform, of course, will be kind of like that, not exactly. A bell shape, kind of symmetry, like a bell, and skew to the right. So most of them on the left, skew to the left, most of them on the right. Right. Now we go to the next section. Additional displays of quantitative data. So this is still quantitative data. Now we displayed a different one. Right. Now, next we have the frequency polygon. So polygon is like a picture that connect between the points, and just like polygon, usually that a closed shape. So a class mid, to do the polygon distribution, we have to get the class midpoint. Which is the sum of consecutive lower class limit divided by 2. So we can say just the average of consecutive lower class limits. Frequency polygon is the graph used the midpoint. We connect on the midpoint, and then at the end we have to connect to the midpoint on the left and the right. I will tell you when we get there. Right. Connect the consecutive points, and then 2 additional lines segments are drawn connecting each graph to the end of the horizontal axis. So we have to focus on that. Alright, now we still have the same example like last time, and with the class midpoint, of course we'll take the consecutive lower class limit, add them up, divide by 2, will give us the midpoint, and do the same thing, the class midpoint, then frequency and relative frequency. That. Next, the question asks us to draw the frequency polygon, so I will do that. Again, there'll be no space. If we start from 0, just do that. I usually start from 0. If we don't want that, just plot kind of like that. Right. Now the class limit is 675. Right. So where do we choose that? We don't put that immediately, but we just skip 1. Skip the first one, and that is the class midpoint. Then skip 1. I mean, not skip 1, just skip. Now we just write the class midpoint. And for the polygon, frequency polygon, we will have the first and the last one. And then so if this is, the class width is 10, still. Subtract 10, we have 6, 65, and plus 10, 6, 7, 45. Right, now the data. 2, 4, 6, 8, 10, 12. Right, so of course this will be the frequency. And it will be time between this disruption. Eruption, sorry. Second. Right, now the class midpoint, we will not use the bar, we choose just one dot. 675, there will be two of them. 685, there's 0. 690, 695. 695, there will be 7. 705, that will be 9. 715 is 9. 725, 11. 735 is 7. Right, so connect the dots. Sorry. Right, the difference in the frequency polygon, we have to connect that to the end. Right, so this is the frequency polygon. So we say the graph title will be time between eruption. Usually the type of the graph, we don't have to say that this is the, we don't have to say the frequency polygon for the time between the eruption. We just give the name for it, but the type of the graph will explain by itself. Right, so that is frequency polygon. Once again, we use the midpoint, and then we connect the midpoint and have to connect to the end. Now if we look at, we look at the graph. By the way, I forgot the name. So time between eruption. Once we have the histogram, we can just use the midpoint with the same height. And we'll just connect all of that, because we have the same thing. Right? So the midpoint is that. Right, so once again, the polygon, frequency polygon, or we could use relative frequency as well. It's a polygon, we just connect them using the midpoint. And the class midpoint is the average of consecutive lower class limit. So we take the lower class limit, add them, divide by 2. We take this to add them, divide by 2, and then so on. Or once we have one increased by the class width. The class width we have earlier is 10, so just plus 10 every time. Right. We can next we can also graph using the cumulative frequency or relative frequency table. So cumulative, what that means? display the aggregate frequency in category, so that aggregate values. Of course, if we can use that percentage as well, but again, it is aggregate values. So, meaning that you count everything from that point and everything before that. So, now, if these are the relative frequency, the frequency, and now the cumulative will be everything up to that point, or the aggregate. So originally there are 2, and the next one there's nothing new, still 2. Next one 7, so we have to add 7 to that. 7 to 2 is 9. Next there will be 9, we add 9 to 9, and there's another 9, and plus 11, and then plus 7. Of course, the last one should be the same number as the total frequency. Right, once again, so we just add everything up to that point, right? Same thing for the percentage. 0.0444, and then the next one, add 0 to it, still the same number. Next we add 0.1556, 0.2, and then add 0.2 to it, 0.4. We just keep adding 0.6, 0.86, sorry, 0.8444, and then plus that 1556, that will be 100%. Right, so cumulative frequency distribution is just adding what we have up to that point, and then the same thing for the percentage. If we graph using the cumulative frequency, the histogram will be all shifts. That's how we say it. And then so here is an example of that. Yeah, so just use the frequency polygon. Of course, because it is cumulative, the graph should be increasing. So that's what we have, right? So the old shifts is increasing. I mean the cumulative data, and just like the polygon. So of course we're not going to connect to 0. We assume the last one should be 1, like 100%, right? So we're not going to connect back to 0, but that's how it works. Because cumulative just getting bigger and bigger, that should not go back to 0 ever. If anything, the total is 100%. Right. Next we have the time series. Well, the time series is usually we use that to monitor trend. So we have some certain time and then some certain values, and then we put that like the price of some certain stock or some currency or something like that. So this is a time series. Right, now we go to the next section, is graphical misrepresentation of data. So even though we correct the data correctly, when we represent them in graphs, make sure that we have to watch out for the following. Right, so let's say we have the years and the life expectancy, right? And we have to look at those two graphs. So what's wrong with this? By the way, this is called the time series, right? So what's wrong with this? Or which one is wrong? I should ask that question too. Right, so what we see here is, on the first one, we see, of course, there is the trend is increasing. So that's good, we know that increasing. But if we see like this, the increasing will be a lot. If it is like this, it could be misunderstood that the life expectancy is a lot, many times greater than that. So the correct graph should be this, because we see the difference exactly. Like this one doesn't look twice as much as this. It is not. We can only look at the difference. So the difference is very small. Right. So watch out for that. Next, here's another example. Here's a survey among how much time they spend preparing for class for each week. So we have that. And also we have two bar graph here. And it says the convention that if it is a pie chart, do not use the 3D because the way it looks. For example, if we focus on this thing, those are about the same, right? But if we look from this perspective, this look a lot bigger than the next one. So that is that, and that is that. So this look a lot smaller than this in 3D. So if you draw the pie chart, don't use the 3D graph. So here are the few things we need. So title and label, that's what we've been doing, right? Avoid distortion, never lie about data. So distortion is what we have earlier. Minimize the white space of the graph. You don't want to have the whole page and then the graph is just tiny bit of this. So try to fill out as much space as we have. If the scale are truncated, be sure to clearly indicate this for the reader. Right. So I'll clearly write that this is space. So it's not go from 0, but there's some gap there. Avoid clutter, such as excessive red line, unnecessary background or pictures. Don't distract the reader. Avoid 3 dimension. We talked about that. Do not use more than one design of the same graphic. You don't want to write the histogram. All of them should have the same set. They have the same graphic. Some graphs use different design for one proportion and then for the others. And don't force the reader to any specific part of the graph. So don't, like this for the histogram, we don't mark that one column differently than the others, or we put some different distraction. Avoid relative graph, devoid the data or scale. So that is the first one we talk about. Avoid that because the scale here will not accurately reflect in the graph. The scale is properly reflect in this graph. Right. So with that, we finished chapter 2. As always, thank you for watching and see you in another video in statistics.